What's your worst nightmare? Mine is a power cut in a lift. You're trapped in a lift. What's the first thing you'd do? You go for the alarm button. Nope, completely dead. You'd go for your mobile phone. 0 bars. Technology is letting you down. There's only one thing for it. Help! Guys, hello! What would happen if the power cut lasted for weeks or even months? But this could never happen, right? Wrong. And the thing that could cause it is right up there. A star of spectral class G and luminosity class 5, the Sun. The Sun is our life source, but it's also a ball of uncontrollable energy. And if all that power was unleashed in our direction, the effect on all our tech will be something like that. Luckily for us, there's a community of researchers who study very real risks like these and how to prevent them. Their work is supported by AXA, and one of their researchers is Dr. Miho Janvier. She studies the sun and has a look at how we can protect the technology that we depend on. Hi, Miho.
Hi, Greg.
This is some stunning footage of the sun. So why is it such a threat?
Did you see that? It's a coronal mass ejection, and that's the very reason why I study the sun. Those coronal mass ejections are big clouds of charged particles that are blasted away from the sun to the other planets. And when they arrive on the Earth, they can affect our satellites, telecommunication satellites, as well as our power grid. We're all relying so much on electricity that we have to be careful on how our sun behavior is affecting us here on Earth.
Okay, so what is it that you exactly look at then?
So what I'm trying to do is to look at how the sun is generating those big solar storms and how they impact the Earth.
Whoa, impact. That's a scary word. What would happen if it hit us?
First, you would have very energetic charged particles that would travel almost at light speed from the sun to the Earth, and that would have fried electric systems on satellites. Then a few hours later, you would have had this big cloud of charged particles traveling from the sun and hitting the Earth, creating northern lights or southern lights. Beautiful, I agree, but they would have induced very strong currents. But because they're so powerful, they're melting the transformers. Until you replace those transformers, you can be out of power for hours or for days.
As Miho said, a CME, a coronal mass ejection, is a cloud of charged particles. And when it hits the Earth's magnetic field, it sends it going like crazy. When that changing magnetic field hits metal on the Earth, so wires, pylons, it causes something known as induction. I can show you what that is with this simple bit of kit. If this magnet represents the changing magnetic field around a coil of metal on the Earth, you can see it induces a current. Now what's happening is the magnetic field is actually moving the electrons inside the metal and causing the metal to heat up ever so slightly. So if you have a big enough magnetic field, you can move the electrons enough that it gets mega hot. Like this induction furnace. Most power grids are running at near to capacity. So even if a solar storm induced just a small amount of current, it would be enough to blow the lot. So everything that relies on power or satellites would be useless. Right, Miho?
That's exactly right, Greg. And this is why research like mine is really important. It's a bit like forecasting the weather. You wouldn't really go out for a walk if you knew that a hurricane was going to arrive, right?
No.
Well, similarly, if we know that solar storm is directed towards the Earth, we can protect our devices by turning down the electricity grids or the communication satellites so that your stuff and my stuff are all protected.
Well, I tell you what, I am very glad that you've got us covered. Great to speak to you. Thanks, Miho.
Bye, Greg. Really nice to talk to you.